The Earth as we know it today is very old, aging over 4.5 billion years. In her youthful days, the Earth had an ocean all right, but one made of magma rocks, liquefied by heat called magma. Some scientists suggest that the Earth's water makeup resulted from asteroids and comets paying a bombarding visit to Earth. This theory is supported by the fact that the ratio of elements, specifically hydrogen and deuterium, found in both oceans and asteroids are similar. Whether this is enough to explain that much water on and even under the Earth is questionable. Others have proposed that the solar nebula, a leftover cloud of gas and dust after the solar system was formed, might have a part in this story. The solar nebula comes from the nebular hypothesis. This hypothesis proposes the concept of a spinning cloud of dust and light elements that flattened into a disk and became the solar system as a way of explaining the formation and evolution of the solar system. Hydrogen from the solar nebula got attracted to iron inside the Earth and couldn't resist being drawn to it. Deuterium, on the other hand, settled for life with the magma, which cooled to form the Earth's mantle, located 2,900 kilometers below the Earth's crust. These theories, like many others in science, have uncertainties and questions that are yet to be answered. Another explanation for underground water cropped up after a ring woodite from the mantle's transition zone landed on the Earth's surface in 2014 after a volcanic eruption. A ring woodite is a mineral formed under high pressures and temperatures in the mantle. After examining the rock, scientists inferred that the transition zone of the Earth did not only have a lot of water, but the combination of all that underground water trapped in the minerals could be worth all the oceans combined, if not more. Water was the common determining factor for the formation of the first forms of civilizations, such as the Nile for the ancient Egyptians, the Yellow River for the ancient Chinese, the Euphrates rivers for the Mesopotamians, and the Indus for ancient India. These civilizations required water for their basic needs, as well as transport, crop irrigation, and the formation of hydraulic empires, government structures maintaining power through sole control over water access. Water makes up over 71% of the Earth, which explains why the Earth is a blue planet, because its water reflects only blue light upon illumination. The abundance of water on Earth seems exciting until you realize that only 3% of it, fresh water, is useful to humans. The ocean is not only distasteful, but harmful for humans to drink. It is saltier than the urine the body excretes. So you can imagine the pressure the poor and already worked up kidneys would be under just to eliminate the excess salt from the seawater, aside from the one it already eliminates because of food consumed. Of the freshwater left for use, 69% of it is ice, 30% of it is beneath the earth as groundwater, and less than 1% is found in rivers and other freshwater bodies. In conclusion, we have just about 1% of water on the whole planet's surface available for human use. To mention a few of its chemical and physical characteristics, water is made up of oxygen and hydrogen atoms, which are very light compared to other atoms. Some compounds heavier than water are found to be in a gaseous state. Per the rules, water is supposed to be found as such. But, as you know, we can drink it. Imagine all water existing as gas. Perhaps we would be dried up and out of Earth much faster without the help of a pandemic. Water also exists in solid form as ice, and even break more rules. Solids are generally known to be denser than liquids, which explains why they sink when placed in liquids. This is the reverse with water. The ice rather floats on top of the water. Water is in its most dense state at 4 degrees Celsius, and as it gets to its freezing point, which is 0 degrees Celsius, the hydrogen bonds in the H2O structure become more open, which drives water molecules farther apart from each other, making them lighter. This out-of-line nature provides benefits that water wouldn't have in another state. The floating ice on the water insulates the rest of the water body, preserving the aquatic life. Water is also known as a universal solvent. Not that it literally dissolves just anything. Have you tried washing your hands with only water after dipping them in oil? Exactly. However, water easily dissolves many, and I mean many, things. Because of this property, pure water is believed not to exist. Water can dissolve minerals and gases by surrounding the solute and breaking its bonds apart. This ability of water is useful in blood to dissolve drugs, oxygen, and nutrients, and carry them to the body parts that need them. Cohesion refers to water's attraction to other water molecules, and this attraction results in a force called surface tension. This force is demonstrated when a lightweight needle is carefully suspended on the surface of water. Even though the needle is denser than water, the cohesive force is formed by hydrogen bonds, which are stronger at the surface of the water than below it, helps water resist the needle's weight, preventing it from sinking. Though water molecules are attracted to each other, they also don't mind mingling with molecules of other kinds when they get the opportunity. This is termed adhesion. The cool vibe water has with molecules of its kind, as well as others, makes it powerful enough to overcome gravity. This phenomenon is termed capillarity. Imagine yourself at the beach on one hot summer afternoon with a cup of iced tea, and right before you take a sip, you notice that the drink has already risen halfway up the straw. The ability for water in the tea to rise through the straw is a function of the adhesion and cohesion forces. Capillarity is perfectly adopted in the body to draw blood through the blood vessels. It also accounts for how nutrients and water rises from the roots to the leaves of plants. Water's high heat capacity also implies that it requires a relatively high amount of heat energy to change its temperature by 1 degree. This character of water makes it a good store of heat energy, enabling it to control temperature changes in organisms, in ecosystems, and the globe at large. The latent heat of vaporization of water helps the body to release excess heat by sweating. The sweat that comes out of the body carries the excess heat, which is released into the atmosphere, leaving a cooling effect. Water is the foundation for all human civilizations. There's more about it that we didn't mention here, and there's still more that we don't know yet. But there's no denying the one fact that we wouldn't be here without it.